Okay, today we are going to discuss about the assignment number 11, dealing with materials data collection, analysis, and interpretation. So let's go to the question number one directly. Uh, so the following statement is or are correct about uncontrollable factors of experiments. Okay. So you take one by one all the options. The factor which does not affect the response. So if the factor doesn't affect the response, means we don't have to worry about it. So this is not the correct answer. Then factor which affects the response and can be controlled. So if it can be controlled, then doesn't come under the uncontrollable factors. This is also not under then the factor varies with a normal distribution like random error, which means like it is a random error. So random error is an uncontrollable factors of uncontrollable factor. For example, like if you are picking some 10 random samples from a group of 100 samples, so generally the samples are assumed to be in the normal distribution, and sorry, the population is assumed to be in normal distribution, and whatever sample which we are picking also is assumed to be in normal distribution. So, if some error occurs, like randomly, if some error occurs which doesn't have much reproducibility, then that is one of the uncontrollable factors of the experiment. So, factor varying a normal distribution like random error. So, then factor which cannot be increased or decreased as per the requirement. So, this for this a good example is if you are conducting the tensile test or any kind of test which is sensitive to the weather, like if you the best way for controlling the environment is by adopting the air conditioner. So where you can increase or decrease the initial temperature or room temperature conditions, you can increase or decrease. But what if you conduct the experiments in the ambient conditions, like whatever the weather changes, we can't do anything about it. So those factors also are uncontrollable. So these two are the correct answers. So yeah, going to the second question. So suppose an experiment need to be designed to study the effect of three factors. So the three factors are temperature, pressure, and catalyst concentration and chemical reaction. The output response is the rate of chemical reaction if both temperature and pressure have an interaction. So the temperature and pressure is having some interaction because they are generally related by some. If it is a gas, they are related by ideal gas law. So they are supposed to have an interaction. So the one factor at a time method is the correct method for doing the experiment is the statement which they are given. So what is the thing what is the one factor at a time method. One factor at a time means we will consider only one factor among all the other factors. We consider the fact whatever we are considering as a significant one, and the remaining factors as insignificant. So the best example is like if you are plotting the grain growth versus temperature. So if the grain growth happens with increasing temperature, grain size is increasing. This could be one of the example where we are only considering the temperature as the factor here. But this is also governed by many other things like what is the initial strain energy, or what is the pressure, or what is the chemical species present. So we are neglecting all the other species. So this is called one factor at a time. We are considering only one factor among all the other factors. So some of the advantages are like it simplifies the estimation or it simplifies the design of experiments. But the issue with this is it is less reliable and has a lot of limitations. So here, since we have three factors, it's like temperature, pressure, and catalytic reactions. Each has two. Okay, fine. So it is like one. If you have read the I will explain you in simple conditions. Like if you have solved for binary uh, binary conditions. Like if you have 111, it's like 111, 110. Likewise, if you go, you have eight combinations. Similarly, we can conduct eight different experiments out of the three given factors. So out of which we are taking only one factor, which is temperature, and we are doing this. So this is false. Here's the third question. According to R.A. Fisher, what are the basic principles of design of experiments? So according to R.A. Fisher, he has given this triangular kind of explanation where randomization means picking the samples or whatever test conditions which you are going to do in a random way. No, it should not have any bias towards some particular samples. In that case, the design of experiment fails. And also replication. So replication means we will be doing many tests to see whether the data can be replicated. So in this way, we can reduce the errors, whatever random errors which can occur in an experiment that can be reduced by taking an average and standard deviation of it. Then blocking. Blocking means it is like if you have 100 specimens, you have to group them in a specific way, so that each lot or each group can be tested and the results can be reproduced. So this is the three principles which is defined by the R.A. Fisher for the design of experiments. Repetition is just like replication. So factorial design and sequentiality, these are little advanced things for the design of experiments. But R.A. Fisher only discussed about these three things. Then the fourth one, consider three factors: temperature, pressure, and catalytic concentration, and two levels, high and low per factor. Only pressure and temperature has a two-level interaction or two sides of the orthogonal design matrix. Okay, so first we have to find what are the design degree of freedoms as arising due to the factors and everything. So number of factors is three. So degree of freedom arising from factors is three. And since they have a response, like they can have a different response with each other. If they are not the response is zero means like then okay. Right. Here two levels per factor. So okay, one second. Okay, so degree of freedom arising from the number of factors is three, with two levels and per factor. Only pressure and temperature have two level interactions. So the area for freedom coming from the interaction is one, because among two there is among three only one two level interaction between temperature and the pressure. So what will be and generally like for whatever equation we are defining, we will have an error constant. So for that we have to define one degree of freedom. So total degree of freedom which degree of freedom given by 5. So as we know, the value of this degree of freedom should be greater than or equal to 2 power n. So here, if it is 4, then n can be 2, and only 4 tests are enough. But since it is 5, we have to conduct 2 power 3, is 8 tests to complete the orthogonal matrix. Yeah, so answer is to the power 3. Going to the fifth question, which are all the following statement is correct about design of experiment? So primarily design of experiment is to either optimize the process parameters by conducting optimum experiments, correct number of experiments, or it is used to study the effect of individual process parameter on the response. How individual factors or parameters affects the output. So for that we can use DOE. Then it is used to study the interaction between the independent variable or response. So interaction between independent variables on the response. So then, but developing a new process is incorrect because to develop new process, there must be some other process, there is some other techniques. For the existing process, how we can optimize all these things. That is the motto of the design of experiments. For the sixth one, in a graphical analysis DOE, the main effect plot gives the idea of each factor affects the response of each value. If one factor, input factor, is most impactful to response, then slope of the representing factors. Okay, if this is given based on the slope. For example, if there is no much response means it is flat. If it is having slightly high response means slope is little high, and so it's less. But when it is having strong response, impactful response means the slope is more steeper. So as it gets more dependent, the slope gets steeper and steeper. So answer is steepest. But based on the output, whether it can be positive or negative. Can be positive or can be negative, but it is steeper. Since it is having impactful to the response, the factor is impactful to the response. Similarly, for the next question, factorial design is carried out to study the effect of three factors on response. Figures are representative of the interaction part. What should be the conclusion from the plot? See, if two plots are having some interaction, then they will cross over each other. So like this. If there is no interaction between two factors, they are independent measures, they will be parallel. So if it is not parallel, they have some uh, interaction. So here, if you see in both the curves, then the first curve there is no interaction because they are parallel, but in the second curve there is an interaction. So what are the given options? Let me see once. Okay, in this factor A and B has factor A and okay, this is between A and B, this is between A and C. So factor A and B has no interaction. So this is correct. And factor A and C has some interaction because they are crosswise. So this is correct. So B and C are both correct answers. Okay, this assignment 11 is done. So if you have any further queries, you can write me to the particular mail. Just add my mail ID here. Yeah, thank you.